Good morning, students. Students, the last class we have completed our first lesson, that is matter around us. Today we are going to start the next lesson, that is atomic structure. Last class I have given few question answers also. I hope that you all studied. Okay. Today we can see the second lesson, brief, atomic structure. This is not a new topic for you. Already in the grade 8 you studied what is atom, what are the different components present in the atom, etc. Isn't it? Now we are going to learn little brief. Okay. So matter. First lesson we have studied matter. What is matter? All the substance that present in the universe is called as what? Matter. It comprises of both living things as well as non-living things. But it should possess two important properties to be a matter. What are they? It should possess mass and space. Okay, mass and space, isn't it? So light, energy, sound, these are not considered as what? Matter, since it does not possess mass and space. And these matters are made up of atoms. All the substance present in the universe are made up of the smallest particle called as what? Atom. Hence we can say that atoms are the building blocks of matter. Atoms are what? They are the building blocks of the matter. Okay, so matters are made up of smallest particle called as what? Atoms. And the first idea regarding this atom was given by the scientist John Dalton. The first atomic theory regarding atom was proposed by the scientist John Dalton. He is the scientist who named the smallest particle as atom. He is the scientist who named the smallest particle as what? Atom. He took this word from a Greek word. He took this from a Greek, that is atomos. Greek word what? Atomos. The meaning for atomos is indivisible. According to John Dalton, atoms are indivisible. But later on it was found that atoms are divisible in modern atomic theory. Okay. So most of the postulates given by John Dalton was later on found to be wrong. Okay. Among that it is also one. He said that atoms are indivisible, but later it was found that atoms are divisible. And what are the components that present in the atoms? Atom has subatomic particles. So what are the subatomic particles present in atom are proton, electron and neutron. Proton, electron and neutron. Protons are positive charge, electrons are negative charge and neutrons are neutral. Okay. And these three are the important subatomic particles. And also atoms have of two parts. Atom has of two parts. We can divide the atom into two parts. One is nucleus, next one is orbit. One is nucleus, the next one is orbit. Okay. This proton and neutrons are present inside the nucleus, where electrons are present outside the nucleus. And the path in which this electron revolves, this circular path, is called as orbit. So, atom has two parts. What are they? Nucleus and orbit. Nucleus and orbit. The nucleus contains protons and neutrons, whereas the orbit contains what? Electrons. Isn't it? See, here two positive charge, whether they will be attract each other? No. You know that same charge cause repulsion. To overcome this repulsion only, the neutral charge, neutron, is placed inside the nucleus. Now, did you understand what is the reason for this neutrons inside the nucleus? To overcome the repulsion force between two positive charge. Two protons cannot be kept inside this small nucleus. They will repel. To overcome this repulsion only, what is present inside? Neutrons are present. Okay. And also see, the mass of the atom depends upon the nucleus. Okay. For an atom which contribute mass means it is nucleus due to the presence of protons and neutrons. Okay. So the mass of the atom totally depend upon the nucleus. Nucleus inside what is present? Proton and neutron, which contribute mass towards the atom. Hence the matter also possesses what? Mass. Whereas the mass of the electron is not considerable mass is present, it is negligible. Okay, electron does not have considerable mass, so it is negligible. Which one only contribute the mass to the atom means proton and neutrons. Okay, students. So once again, what is the chapter name? What's the chapter name? Atomic structure. The word atom was given by whom? The scientist John Dalton. What is the meaning for? It is taken from the word which one? Atom is meaning what? Indivisible. Three important components are there. Proton, electron, neutron. Proton and neutron present inside the nucleus. Electrons present outside the nucleus. And the mass for the atom was given by the nucleus. It's totally depend upon the nucleus. Okay, ma? And so each component was discovered by different persons. So now we are going to learn about the discovery of these subatomic particles. Okay, first we are going to see the discovery of nucleus. First we are going to see who has discovered the presence of nucleus in the atoms. Okay, shall we see? See next, the discovery of nucleus. So in the year 1911, Lord Rutherford, okay, the scientist who discovered nucleus is, students don't forget, who discovered the component nucleus? Rutherford. So the nucleus, the presence of nucleus inside the atom was discovered by the scientist Rutherford by a gold foil experiment. He found nucleus. By using gold foil experiment, he found the nucleus. For this experiment, the two important things is he took gold foil and alpha rays. Okay, so discovery of nucleus, it was discovered in the year 1911 by the scientist Lord Rutherford. Okay, by conducting a gold foil experiment. He discovered nucleus. For his experiment, he took a thin gold foil and alpha rays. Why he took this gold element means it is highly malleable and ductile, isn't it? We can stretch, isn't it? It's highly malleable. Malleable and ductile means we can make as thin as possible, and also it can be stretched for a long distance, isn't it? So it is highly malleable. For this experiment, he needed a thin component. So he took a thin gold foil. Silver foil, aluminum foil you might see in, isn't it? Aluminum foil you might see in, okay? And also chocolate covers, did you look? Silver color, like that, aluminum foil will be there. So instead of that, he has to what? Gold foil, okay? Foil means now you might understood how it is, okay? Aluminum foil you might see like that here, gold foil, because it is highly malleable and we can make as thin as possible. So for his experiment, he took gold foil and also alpha rays. Alpha rays are nothing. He took a source which will produce alpha rays. Here radium. He has taken radium which emit alpha rays. Alpha rays are nothing. It carries positive ions, that is helium ions, helium ions 2 plus, okay, 2 positive charge it has. So alpha rays carry what? Alpha rays carries what particles? Positive charge particles. Alpha rays carries what particles? Positive charge particles. So the two important components in his experiment is, one is gold foil, next one is alpha rays. Alpha rays, the source which emits alpha rays is radium. And this rays carries what ion in it? Positive charge, that is helium ions. Alpha rays carries what ions? Helium ions, which are positive charge. See students, this is the diagrammatic representation of gold foil experiment. This is the diagrammatic representation for gold foil experiment. This is source which emitting alpha rays. So radium, here you can take, it is a radium source. Here it is a radium source which emit alpha rays, okay? And here a gold foil, a thin gold foil is placed and it was covered by a luminescent screen. Why means it is a white screen to detect the alpha rays. How these rays are passing. So through this luminant screen we can see the difference in the rays. Okay, so radium source which emit alpha rays. So this is a beam of alpha particles which are carrying helium ions. Okay, when the source is on, it emits alpha particles. This is gold foil. It was covered by a luminous screen. Through the screen we can see the difference in the alpha rays. Okay, now when the source is on, it emits beam of alpha particle. It emits what? Beam of alpha particles which carry helium ions. It carry what ions? Helium ions. So it is carrying a positive charge. So it strike on the gold foil. It strike on the gold foil, and here the rays are getting some variations, and it can be seen through the luminance screen. Okay. So now did you understood the path of this diagrammatic representation? And now we are going to see what happened when these alpha rays hit to the gold foil. What happened when the alpha rays hit the gold foil? That only we are going to see. See here, the ray is coming straight. It hit on the gold foil at the center. Okay, falls. See, some rays, they are bouncing back. Okay, and what happens in this gold foil when the alpha rays strike? That we can see in this diagram. Okay, see, consider this is the atom that present in the gold foil. This is the atom present in the gold foil. So these are the alpha particles that is coming towards the atom. Some alpha particles, they passed straight through the empty space that present in the atom. Some, they deflected. They get what? Deflected. Some, they bounced back. Okay. Few rays, through the luminance screen we can see. Okay. Few rays, they went straight. Few of them get deflected. And few of them bounced back. One or two rays that get bounced back. Why these variations? He analyzed the reason for these variations. Okay. So Rutherford analyzed the variation. Why few are going straight and few are bouncing back and slightly some rays are deflected. From this he came to a conclusion, and he put forward the theory called as Rutherford atomic theory. From this gold foil experiment, he analyzed the results, and under the heading Rutherford atomic model, he showed few results. Have you understood, students? So rays are coming, hitting on the gold foil. There are several deviation in the rays. Through the luminance screen we detected, and we found that few rays went straight, few bounced back, few deflected. What is the reason? From this he concluded that, since these rays, alpha rays also, positive ions. So it is hitting directly to the center. The rays which hit the center of the atom only get bounced. So at the center what may be present? Heavy positive charge. So we know that positive cause what? Repulsion. Due to here the heavy positive charge only, what happened? The rays get bounced back. Did you understood, students? See, students, here fully positive charge at the center. Here fully positive charge. Nucleus. Here also the rays also carrying what? Helium ions, that is carrying positive charge. Positive, whether they will attract, they will repel. So only the lines which head to the center of the atom get bounced. Okay. And few went near to this nucleus. Few rays that went near to this positive charge, due to the repulsion, it get deflected. Which get strike on the center get bounced. Which are far away from this nucleus went straight. Did you understood? So which hit at the center get bounced, which went far away from the nucleus went straight, which went near to the nucleus get deflected, because at center what is having? See what? It has positive charge. It has what? Positive charge. The rays also carrying positive charge. Positive cause repulsion. Hence only we get bounced back. Which is sent near to this nucleus get deflected. From this Rutherford concluded that is a heavy positive charge at the center of the atom. That is the reason why the rays bounced back. Have you understood? So at the center of the atom has what? Heavy positive charge, and that positive charge only he named it as nucleus. He does not found it is a proton. He just found that positive charge. That center part is what? Nucleus. Nucleus. Neutron was later on discovered by James Chadwick. Okay. Here he discovered that at the center a heavy positive charge is present, and that positive charge only he named it as nucleus. From this he concluded several points under the heading called as Rutherford atomic model. Very important question. The conclusion he made from this experiment. First one is atom has large empty space. So only many of the rays went straight. The line which passes through the empty space went straight because there is no obstacles to hit. So it went straight. So first point, large empty space. Atom has what? Large empty space. The first point regarding atom, he has said what? It has large empty space. Okay. So only all the alpha rays which went through the empty space went straight. Then he said that at the center there is a positive charge and he named it as what? Nucleus. He named it as what? Nucleus. He named it as nucleus. The center part, the positive charge at the center, he named it as what? Nucleus. And the size, he found that the size of the nucleus is very small. Only it is found at the center and it is very, very small. It is very, very small and the size of the nucleus is responsible for the mass of the atom. Okay, the size, when comparing to the atom, the size of the nucleus is very, very small and it is found at the center. He named, okay, the positive charge at the center and it is very, very small in size. And he said that the electrons revolve in circular path. The electrons revolve in circular path. Okay, so this is the atoms. It is the nucleus and this is the circular path. Okay, the outer path. This round circular path is called as what? Orbit. The circular path is called as what? Orbit. So he said that electrons revolve in circular path. And he also said that atom is electrically neutral. Isn't it? What's the charge of the atom? Atom does not have charge. It is neutral. Atom does not have any charge. It is neutral. Why? Means number of proton is equal to number of electrons. Number of positive charge is equal to number of negative charge. Okay. See, if it is 5 protons are present inside the nucleus, outside the nucleus it contains 5 electrons. So 5 positive charge, 5. So what is the total charge? 0. What is the total charge? 0. So atom is electrically neutral. Atom does not carry any charge. The center part only has what? Center part what it is have? Positive. Here fully positive. Here empty space surrounded by the electrons which rotate in the circular path. So number of protons and number of electrons. Here 4 positive means here 4 negative. So total charge of the atom is said to be what? 0. Total charge is said to be 1. So atom is electrically neutral. And he said that the arrangement of electrons in the atom is like a solar system. Like a solar. You all know solar system. What is present at the center? Nucleus, and all the planets revolve around the what? All the planets revolve around the sun, isn't it? So like that here also, nucleus is at the center and all the electrons revolve around the nucleus. You can see here, for example, this is nucleus and here all the electrons revolve around the nucleus. They carry what? Electrons, which revolve around the nucleus in a circular path. Okay, so it looks like a solar system. It looks like a solar system. So what are the conclusion he made it? It has large empty space and the positive charge at the center named nucleus, and this nucleus is very, very small and the electrons revolve in circular path. The total charge, atom is said to be electrically neutral because number of proton is equal to number of electron, and he compared this to a solar system because he consider nucleus as the sun and the circular path which carrying electron as a planet. So how the planets are rotating around the sun, like that here also the electrons are revolving around the nucleus. Okay, this is about what? Rutherford conclusion about his experiment. Did you understood, students? So from this experiment only he found that atom has empty space, small nucleus at the center, and it is totally, the charge of the atom is 0. Okay, have you understood? Yeah. The next one, limitations. Limitation means we can say the drawback. The next one we can say as limitation. Limitation means, students, you can say it as a drawback. What's the drawback in his experiment? Okay, whatever he said is right, but a point. What did he said here? 80 electrons revolve in circular circular path. Electrons revolves in circular path like a solar system, we said, isn't it? Here, according to electromagnetic theory, one electron, see, consider this is a nucleus and this is the electron, the circular path, it is rotating up and down. Okay, see, take a small stone, tie it to a rope and take that is like a swing. With the help of your hand, you swing that stone. What will happen? When you apply force, first you apply with a heavy force. Have you understood, students? Take a small stone, tie it with a rope, long rope, and you rotate that stone in a circular motion by applying a force. When you are applying force, it will take a long distance to rotate. If you keep it same for few minutes, what happen? The path will get reduced, isn't it? First, it will rotate, it circulate in a long distance. After that, the distance will get reduced. Finally, it falls on your hand. That is happened, isn't it? You try at your home. Okay, when you swing this stone at a high speed, so it take a large, it occupy large space. Slowly, the length will get reduced. Finally, it will fall on your hand. We know that, isn't it? Like that here also, when an electron, it is moving from, see, from lower level to higher level. When it is moving constantly, at a point, it lose energy. It lose what? Energy. Okay. And what happened? This electron will come and falls on the nucleus. So the nucleus become what? Unstable. But already the scientists found that atoms are what? Stable in atmosphere, isn't it? Atoms are stable in universe, isn't it? All the things that present in universe are stable. Hence, atoms are also what? Stable. So when it lose energy, the electrons will fall on the nucleus if it is moving in such a path. And atoms become unstable. But already it is found that atoms are what? Stable. Then he did not prove what will happen to this. Okay, further he did not prove. He did not prove the stability of the atom. According to him, if the electron rotate in such a direction, it might fall at one position, it lose energy and it falls on the nucleus. If it happens means atom become unstable, but atoms are stable. So Rutherford failed to explain this. So this theory comes to failure. Okay, so atoms. Again, this was proved by the next scientist, Niels Bohr. The next scientist whom? Niels Bohr. Okay, so students, in this class we have studied what? Discovery of nucleus with the help of what experiment? Gold foil experiment. We have studied how Rutherford discovered nucleus. The center, the heavy positive charge at the center only, he named it as what? Nucleus. Okay. And what is the limitation? He said that electrons revolve around the nucleus in such a direction. So according to this, what? It will lose energy and fall on the nucleus and atom become unstable, but atoms are stable. He failed to prove this. Okay, so this is the drawback. This is the limitations of Rutherford. Next class, we will study about Niels Bohr's atomic model. So today we have learned Rutherford atomic model. Next class, we will learn about Niels Bohr's atomic model. So students, Roman number 8, take your books at the back. Evaluation part, Roman number 8, first question. Okay, what are the conclusions Rutherford made from gold foil experiment? What are the conclusions? These are the conclusions. These are the conclusion he made from this. Isn't it? Large empty space, only the line went straight. Due to positive charge, it get bounced. And outside what will present? Electrons. It is electrically neutral and it is compared with solar system. This is the conclusion. So page number 126. So students, Roman number 8, first question. The answer is on page number 126. 126 under the heading Rutherford atomic model. Mark that question and learn that question. It's a very, very important question. So students, next class we will study about Niels Bohr's atomic model. Please learn this question and also write this question on your booklet. Okay, already I told you to write few questions. I hope that you all completed that assignment. Along with that, you put heading as lesson 2, what? Atomic structure, and write what are the question along with this answers. That is next class we will learn about the next topic. Thank you students.